Okay, so today we are going to learn about some more concepts, some more formulas. Like in last class, we have learned about multiple angle formulas that I have noted down here, multiple and submultiple angle formulas. Now we will be having transformation formula. So we can remember the formulas by the name of the formulas. This transformation formulas. There are two types of transformation formula. First type is sum to product. Means if you can transform or you can convert summation to product. What are the formulas under that? The first one is like this. Sin C, C is the angle, plus sin D. D is also angle. Sin C plus sin D, it will be 2 sin C plus D by 2 into cos C minus D by 2. Okay, so what do you see here? There is a plus sign. This means sum. Plus means sum. It is converted to product. Here there is a product between terms. Okay, so when we need to convert sum to product, we can use transformation formula of this type. There is another one in sin, that is sin C minus sin D. If I have a minus sign in between, then it will be converted to 2 cos C plus D by 2 into sin C minus D by 2. That means when you have plus sign, then we have sine of C plus D by 2. So for C plus D, we have sine here, here we have cos. Here we have cos, here we have sine for C minus D. So changing like this. That is how we can remember. Now another one in terms of cos will be cos C plus cos D, that is equal to 2 sine 2 cos C plus D by 2 into cos C minus D by 2. So here both are cos. Both are cos, and there is no issue here. But when I have cos C minus cos D, then we will be having 2 sine C plus D by 2, both will be sine in this case. But the last angle is not C minus D, it is D minus C by 2. Okay? Or this is also written as minus of 2 sine C plus D by 2 into sine of C minus D by 2. So if you want to maintain this type of angle, C plus D by 2, C minus D by 2, that order, then you have to put a minus sign before. Because if you take minus common from this, if you take minus common, that will come before this term. Okay, so these are 4 formulas under sum to product transformation. We also have product to sum transformation. So we will list them down here. Product to sum transformation. What is that? It is like this. When I have 2 sine A cos B, so product that will be equal to sine of A plus B plus sine of A minus B. So there is a product between the terms here, which is converted to sum. If we need to use such idea, we can use this formula. Also, this can be easily proved by using sin A plus B and sin A minus B formula in the right hand side. And if you add those two, you will get this. Okay, that is simple. And number 2 under this is 2 cos A sin B. So sin A cos B, now it is cos A sin B. This is nothing but sine of a plus b minus sine of a minus b. Okay, so when first sine then cos, then a plus, first cos then sine, then a minus sine. So that is how we can remember. Number three, 2 cos a cos b, 2 cos a cos, that is cos a plus b plus cos a minus b. You can just use this compound angle formula in the right hand side, as I told. You can add them and you will get this. Number 4 is 2 sine a sine b. For this we have cos of a minus b, that will come in the first position, and then minus cos of a plus b. So there is a small difference in formula number 4 here, as well as here also there is a small difference. I mean, they are this formula number 4 is little different from 1 to 3. 1 to 3 are similar. Okay, so these are transformation formulas. What type of question can you solve from here? Let us take a question. If we have to find sum of if a plus b plus c is equal to pi, 180 degree, then prove that sine 2a plus sine 2b plus sine 2c is equal to 4 sine a sine b sine c. Number 2, we have to prove that sine a plus sine b plus sine c is equal to 4 cos of a by 2 cos of b by 2 cos of c by 2. These two questions you have to solve, and there is a condition given that if a plus b plus c is equal to pi, then this you have to do. So this condition is very, very important. We have to use this condition to prove this statement. Let us see how we can solve. So part 1, LHS is equal to sine 2a plus sine 2b plus sine 2c. Okay, we are going to consider these two terms together, and we are going to apply this formula here. Let me show you. Yes, sine c plus sine b. There are two sine terms, and in between there is a plus sign. So what will happen? Angles will get added and divided by 2, and then subtracted, divided by 2. So if I apply that here, we have this angle 2a and 2b. So angles will get added like this: 2 sine 2a plus 2b by 2 into cos 2a minus 2b by 2. So it is coming from the first two term, and the third term is as it is. There is no change in the third term. It is sine 2c. Okay, now you can see that it is simplified as 2 sine of a plus b, just a plus b, into cos of a minus b after cancelling those 2, plus we have sine 2c. Now we are going to apply our condition. The condition is a plus b plus c is equal to pi. So if a plus b plus c is equal to pi, what will be a plus b? A plus b is equal to pi minus c. Okay, so I am going to put that here. And if a plus b equal to pi minus c, then if I apply sine on both sides, sine of a plus b equal to sine of pi minus c. What is that? Pi minus c means, pi means up to this 180 degree, and then minus c, that means this way. So this quadrant, second quadrant, sine is positive. So it will just be equal to sine c. That is the idea we are going to use. And by using that, we will get this as 2 sine c and cos a minus b as it is. This term sine a plus b, it became sine c because of this relation. And sine 2c I can write as 2 sine c cos c. This is multiple angle formula. Okay. So how did I get this suddenly from sine a plus b to sine c? That I have explained here. Let me bring it down here. Okay, this is the result. Anyway, let that be like this. Now you can see that there is a 2 sine c here, and there is a 2 sine c here also. So you can just take that common, 2 sine c from here as well as from here. We can take it common. So 2 sine c into what will remain? Cos of a minus b plus cos of c. Okay, I have taken 2 sine c from it. So what I did first, I have applied transformation formula here. Let me write it down. At this step, we have used sine c plus sine d, this formula. And at this step, we have used a plus b is equal to pi minus c, this condition. Okay. Here I have taken common. Now I'm going to write it as 2 sine c, and inside bracket I have cos of a minus b. Now we have cos c. What you can apply here, it is like cos of one angle plus cos of another angle. Okay, so it looks like we can apply this concept, this formula, cos of one angle plus cos of another. Sum to product can be used. We can do that directly. We can do that. Cos of one angle plus cos of another. You can use that, but I am not using that here. I am using another one. That is cos c here can be written as cos of minus cos of a plus b. Why? Because we have already seen this relation a plus b equal to pi minus c. So sin a plus b equal to sin pi minus c is sin c. Instead of that, if I would have taken cos of a plus b will be cos of pi minus c, which is minus of cos c. Okay, why? Because pi minus c is in the second quadrant again, and in second quadrant cos is negative. That's why minus cos. So in place of cos c, I can put minus of cos a plus b. That's what I have done here. So in this step also, what I have done, I have used this a plus b equal to pi minus c. This is what I have used at this step also. Okay, so this condition is used 2 times. Again, I am telling you, once it is used here to reduce a plus b to c. Again, we have used the same thing to get c to a plus b. Now, cos a minus b minus of cos A plus B. Directly we have this formula here, cos A minus B minus of cos A plus B. That formula we can use, and we can get 2 sin A sin B from there. So I'll just write this as 2 sin A sin B. Outside we have 2 sin C, and inside bracket we have 2 sin A sin B by transformation formula. So this is also which formula? Product to this is product to sum, but right. This is also transformation formula. And after that, we have completed our solution. We just simplify it for sin A, sin B, sin C, right? So this is our RHS. So again, this type of question, you can use transformation formula at the first step. After that, you have to use some other formulas and conditions, another transformation formula here, and then you can get the answer. Okay. Similarly, we can try to solve the second. Second one, our LHS is equal to sin A plus sin B plus sin C. So of course, I will be applying formula, transformation formula for first two terms, and I will get it as 2 sin A plus B by 2 into cos A minus B by 2 plus sin C. Right. Now here we know that A plus B is equal to pi minus C. Right. I am writing that here, and that will imply A plus B by 2 is equal to pi by 2 minus C by 2. Therefore, our first term will become 2 cos of C by 2. This sin A plus B by 2, it became cos of C by 2 because of this relation. Okay. So, I hope it is clear why it became cos. Because pi by 2 is 90 degree and pi by 2 minus C by 2 is first quadrant. Sine became cos and it is positive. Next term is cos of A minus B by 2, and the other term is sin C, that can be as 2 sin C by 2 cos C by 2. So we are using multiple angle formula or submultiple angle formula here for the last term. Now from these two I can take 2 cos C by 2 common. Okay. 2 into cos C by 2 will be common. If I take that common, 2 cos C by 2 common, will be left with cos of A minus B divided by 2 plus sine of C by 2. Again, it is a sum, so I can try to use some transformation formula with plus to product, sum to product, but we have a cos and sine. There is no such formula. The formulas are either both sine or both cos. Okay. So what you have to do? You have to convert this cos to sine so that both are sine, or we can convert this sine to cos. Okay. Now, again, we can look at this one, that pi by 2 minus C by 2 is equal to A plus B by 2. That's why sine A plus B by 2 became cos C by 2. So now in place of sine C by 2, it will become cos A plus B by 2. So this is equal to 2 cos C by 2 into cos of A minus B by 2 plus cos of A plus B by 2. Sin C by 2 became cos of A plus B by 2 because of this relation. Okay. So Now, what can we do here? This one. It is cos C plus cos B form, or I can say cos of A minus B plus cos of A plus B, where A by 2 is my A. Okay. To make it clear, I will write one more step. That's 2 cos C by 2 into cos of A by 2 minus B by 2 plus cos of A by 2 plus B by 2. So now it is in the form of this formula. First a minus sign, then plus sign, in between here minus. So we have the same thing, first minus sign, then plus sign, in between here plus. In between you have plus, okay. In between you have plus, so it is this one. This one. That means 2 cos equal. So I will get 2 cos C by 2 into 2 cos A means A by 2 here into cos B by 2. When I simplify it, I get 4 cos A by 2 cos B by 2 cos C by 2. And that is the RHS. That is our RHS. Okay. So that is how we can solve this type of question. These are the application of transformation formula. We can have other questions also. I have given you some assignments. You can solve questions from there. There are many applications. One more concept I will tell you here, that is maximum and minimum values of trigonometric ratios. So you can just remember them. You don't have to think about it too much. What is it for sin x? Minimum is 1, maximum is 1. For cos x also, maximum value is 1, minimum value is minus 1. Tan x, there is no maximum minimum. It can take all real numbers. Cot x also can take all real numbers. Okay. So these are the two, and then we have sec x and cosec x. Okay, sec x is greater or equal to 1, or sec x is less equal to minus 1. Similarly, cosec x minimum value is 1, or cosec x maximum is minus 1. These are the limits of these functions. I mean, sin x value should always lie between minus 1 and plus 1, whereas you know sin x and cosec x are reciprocal to each other. So if sin x value should be less than 1, then cosec x value should be greater than 1. If sin x value should be greater than minus 1, then cosec x value should be less than minus 1. That's why these are the. There is one more thing, that is, if I have expression like a cos x plus b sin x, this is the expression. You see, with cos I have a x, with sin also you have a x, same angle, x is the angle, and a and b are real numbers. Then the maximum value of this expression will be root under a square plus b square, and minimum is minus of root under a square plus b square. You must remember this. If required, you can use them. Okay. So this is one of the concepts. Let's take a question here. If we get question like this, that if x and y are two distinct two distinct real positive numbers can the relation sec theta is equal to 2xy divided by x square plus y square be true? Can this relation be true? That is our question. Yes or no? That we have to find. So let us see how to deal with this. You see, our x square plus y square minus 2xy is nothing but x minus y whole square. Can I say that this is always greater than 0 or equal to 0? If x and y are equal, then it will be, means if x is equal to y, then it will be equal to 0. It is given that x and y are two distinct real numbers. Distinct means unequal. Therefore, they cannot be equal. Therefore, they cannot be equal to 0. So just greater than 0 is enough here. So that will imply x square plus y square is greater than 2xy. And that is going to imply 2xy divided by x square plus y square is less than 1, which is going to imply sec theta is less than 1. That is our expression given. Sec theta is equal to that. So less than 1. Is it true? That you have to check. Now I have told you sec theta or sec x is always greater or equal to 1. It can never be less than 1. So therefore, sec theta less than 1 is a false statement. False. So that answer, can it be true? No, it cannot be true. It is a false statement. So let us take another question. So when you have such question, you can use this idea of maximum minimum value of these functions. Another question. Find the maximum and minimum values of 3 cos x plus 4 sin x. So it is like a cos x plus b sin x. I have told the formula, that is 3 cos x plus 4 sin x. A cos x plus b sin x. Maximum is root under a square plus b square. And minimum is minus of root under a square plus b square. So the minimum value is minus 5. And the maximum value is 5. Okay. This is how we can solve this type of question.